All right, so we got a bunch of ideas we're going to be covering here in this video, and you may want to pause, rewind, and watch a few times through. So, um, first off, this is not a polynomial inequality because we got the um, divided by x minus 4, and so in some sense this is a rational expression, a rational inequality, but we can still go through and graph it in really the same sense of what we've been doing so far. So back in the first video for this lesson, talked about finding your zeros and your end behavior, and then possibly your asymptotes. And so let's go through and talk about what those actually, we'll save what those are until we get to them. First, we're only going to worry about the numerator right now, and we're going to find our zeros. So our zeros are at -2 and a double root at 5. All right, so we've got -2. Let's say this is 0, -2, and at 5. So 5. And my scale is not very good. Look at the spaces are all off, but you've got the general idea. So next we're going to talk about asymptotes. And for this problem here, we are going to have an asymptote, and it's going to be where the x value, whatever x value we would plug in, that would make the denominator equal to 0. And so looking at x minus 4, our x value of 4 is going to give us an asymptote. And so here it is right through 4. And what that is, this is occurring at x equals 4. What that is that it's a line that our graph is going to approach and never quite be able to touch. It's either going to scale upward with it or approach and head downward. So we'll figure out a little bit if the two sides are going to go the same direction, if they're going to go opposite directions, or if we even have an asymptote at a certain point. With that, I want to pause and look at some graphs that I put into the calculator. And the first one is 2x plus 3. Actually, I'll write it down here. 2x plus 3 times, what was it? X minus 2 divided by x minus 2. And that was set equal to y. And notice that, x minus 2 divided by x minus 2 gives us 0, gives us 1. And so this graph is going to look just like y equals 2x plus 3. It's going to be a nice linear line. It's going to look something like that. But right at the point of 2, there's going to be a discontinuous point. The graph just kind of stops. There's no asymptote. It's not going to scale up or scale down. It's just going to be a point that's missing from our graph. And so in some cases, we'll have, if you see that graph, there it is. And let's hit the graph. Oh, actually, I'll need to change my window. Notice that it's at negative 9.4 and 9.4. I guess there's 94 pixels on your calculator. And so to actually be able to see the discontinuous point, you need to have the right scale on there. Otherwise, it will plot a point next to it, and you won't actually see the missing point. So here we go. Got it graphed. And notice right here, there's just a little hole. There's not an asymptote. There's just a hole in the graph, and it, other than that, behaves just like 2x plus 3 and graphs on up. So that's that one. Now, I also have graphed the line that we are working on right now, which is x plus 2 times x minus 5 squared divided by x minus 4. And I just set it equal to y. And let's go ahead and take a look at that graph. Okay, and so we can see that some things that make a little bit of sense, and we'll come back and sketch this in just a moment. But notice that on the left side, so as you approach x equals negative infinity, notice that it's heading upward. Likewise, on the right-hand side, as x approaches positive infinity, it's heading upward. And we can't really tell what's going on right here as the window is set right now. We'll come back to that in just a minute. Let's actually start graphing and see if we can figure out what's going on here with this specific problem. So if we consider the numerator, we have an x and then two other x's since it's being squared. And so this on top is a cubic. It's x cubed and then some other stuff afterwards if we were to multiply that all out, divided by just an x minus 4, so divided by a linear, which is an x. That would result essentially, and there's kind of some other stuff going on here, but that will result in a x squared, which is an even power. So our first thing is that this essentially is an even degree, an even power, and so our end behavior, the two ends are going to do the same thing. So either they're going to both head to positive infinity or they're both going to head to negative infinity. We got to figure out which one it's going to be. And so with that, we need to look at our a value, or our leading coefficient. So if we multiply this all out, we'll end up with a positive 1. And at the bottom, there's also a positive 1. So it's a squared, x squared with a positive 1 leading coefficient, meaning that the two sides are both going to head to positive infinity as we graph this. And it's going to start from positive infinity, it's going to come do its stuff, and head on out back to positive infinity. So there's part one. That this is essentially, once we divide it out, if we were to in fact divide it out, our leading coefficient would be 1, and we'd have a x squared term. Now, our asymptote is at 4, but let's go back and put in our roots. We have a root at -2, and we have a double root at 5. And so let's see if we can figure out all the rest of the stuff that's going on here. Just sketching through, if it's starting from positive infinity, it's got a single root at 2. It's got to come on down, and it can't, again, it can't touch this line, this asymptote. It's going to just get closer and closer and closer and closer to it. It also can't head back up again, because if it were to touch this x-axis again, we would have another root, but we already know where our 3 roots are. We got one at -2, and we have 2 of them at 5. So really the only thing that this graph can do is kind of curve towards it and head down along and just head towards negative infinity. Okay, let's kind of keep that in mind. Now on the other side, if it was ending at positive infinity, and it's got this double root, it means it's going to have to be going on down. It's going to bounce off of 5. It can't go through because remember it's a double root, meaning it has to head back up, and it can't head back down again to kind of meet up with this the other side of the asymptote, because we already know all of our roots. If it was going to go back through there, we would need another root, and there isn't another root. And so here we go. Our graph looks a little something like this. And from there we can see where it's positive, where it's negative. We've got enough information just from this sketch that between these locations right here, I want to get my roots and my asymptote as some barriers for me. So the output when x is less than -2 is positive. The output when between -2 and 4 is negative. These output are all negative y values. From 4 to 5, it's positive. Right at 5, it's 0. And then from 5 on, it's positive again. So there's our different boundaries or different areas that we need to consider. And so let's use this graph to answer our question. We're looking for what where it will be less than or negative, less than 0, or equal to 0. And so we have some solutions from including -2. And so from -2 x is going to be greater than or equal to -2, and less than 4. Notice that 4 is not one of our solutions because that's the asymptote. That if you plug in 4 for x, we actually get undefined. It's not even on the graph. There's no point that that's at. And then it's all positive from 4 to 5. Right at 5, x is 0, which works for us. We were looking for ones that are less than or equal to 0. So 5 is part of our solution. And then heads back up to positive. So here's our solution. All right. Now, a few things to keep in mind about asymptotes. So you're not always going to have them. Each graph is going to depend a little bit on the situation at hand. Again, remember our very first one, when we graphed this, there was just a hole. It was just discontinuous. If we graph the second one again, but move our window to include more negative numbers, so we're going to open the window down to -100, we'll get a little bit better picture of what's happening here. So there's our graph that comes down, and notice how it just kind of drops off. Now we're losing some information just due to the pixels, but that line continues on forever because right at 4 there's that asymptote. Now notice that, so back over to the equation itself, that there is 1 x minus 4. Now we could have, and you can think of asymptotes in similar, they're not exactly going to always behave the same, but they're similar to the end behavior, where this essentially is to the first degree, that's odd. And so odd power, if it's an asymptote, will go in opposite directions. Go in opposite directions. And where it's even, they'll go the same. Now they're a little bit tough to try out and to practice, because if we were just to, in this middle graph right here, so let me clear out the first one, if we were to just square this x minus 4, we would be dividing out a whole another x from the numerator, and the graph would just look very different. We wouldn't actually be able to see the asymptote. So what this last graph is, and if you want to pause and type that into your calculator, is that I went ahead and added in an extra x and then squared the denominator. So we got an extra x so that when we divide out an additional x minus 4, the graph itself will change, but not too dramatically. So two things will be happening as we graph this. First, we're going to have another root at x equals 0. But more importantly, check out what happens with the asymptote. So before they were on the negative side of the line, so on the negative side of 4, it was heading to negative infinity, and on the positive side of 4, it was heading to positive infinity. And change our window here. All right, Ymax at 100. And so I'm going to graph this and just and take a look at it. Did I miss it? Oh, got to make sure I tell it to graph it. All right. So notice, just like before, the graph is coming down. It goes through -2. Now that root of 0 that we added in is added in, but which allows it to kind of head back up. But see how the two are both heading to positive infinity now. If I were to zoom out even more, let's try 500. Goes through 2, comes up at 0, and notice really there's that asymptote right there at 4. On the negative side of 4, so like numbers like 3.9, 3.99, it's heading to positive infinity, and on the right side, so 4.1, 4.01, so on and so forth, also heading to positive infinity. It's incredibly close to that line, but it never actually reaches it because x can never equal 4. All right, now that was long, but I do hope that helped.